Hola, hola, hola. Probando, uno, dos. Welcome, everyone. It's good to see you again. I hope you're
Morning,
doing
mister.
good morning. Okay, guys, welcome one more time with another geometry class. Please, before the class start the class, please turn on the camera. Please, Victoria, Randy, Gabriela, Oscar, Juan, Manuel, Marcela, Efraín, García, Agustín, Visco, Pineda, Juan Castellanos, please turn on the camera. Okay. Today, we're going to learn one of some lessons or topics. And sometimes we learn in the basic geometry. Actually, we're going to learn what will be the circle. But what is the definition of the circle? But this time, we're going to study a little bit deeper the definition, so the property of the tangents around the circle. You know, actually, we know what is the circle. We define what is the concept of the diameter, what is the concept of the radius, and but we don't know what is the rest of the parts of the properties of the tangents of the part of the circle. Okay, thank you, Miss. Well, let me know. So in this situation, as soon as you can see, we have the circle whose circumference is given by 2 times pi radius, okay? But the parts of the circle is divided by the diameter, the radius, the chord, the secant, and the Poisson tangency. We're going to define what is the definition for every one of them, because at the moment to calculate those values, believe me, this is not a big deal, this is not complicated thing. The only thing that we have to do is identify the difference between them. For example, what is the definition of a circle? Well, we can divide a circle like this is a set of points in a plane. Is a set of points in a plane. Is a set of points in a plane, according to the definition. There are equidistance that are equidistance from a given point from a given point from a given point called the center of the circle. Okay, what does that mean? It's the word equidistance. Equidistance, my dear students, read that they sorry, they're saying we have the same distance, but the point, like the red point is called like a center. Actually, this red point located over here is what we call the center. And what does that mean? If you're pointing that point to center for the space, actually the distance between the center to every point of the circle is called the radius, right? But this distance will be the same, right? This is the definition for a circle. Remember, even though we have a circular line over here, but inside this circular line that we call the circumference, we have a set of points. And this set of points, actually, all of them, obviously, to create a circle that will be located in the same plane, right? And that's why we have a center, and this center, when we connect with one single at this point, we have an equidistant distance. This is going to be that definition of circle. Okay. And that radius, just like what I'm saying, that radius, according to the definition, is a segment whose endpoints is a segment whose endpoint is a segment whose endpoints are the center and any point. The center or any point. Or any point on the circle. So, or simple merely works. The problem, the definition says, is a segment whose endpoints are the center or any point of the circle. For example, we have the initial point, ending point over here. The blue one, or could be, or for example, this red point with this red one over here, that will be another endpoint. So, just in simple English, what is the definition of the radius? Well, the definition for radius is the distance that connects the center of the circle with any equidistant point. It's a simple merely words. What will be that definition from the radius? Now, the next part of the circle, the chord. What will be that definition from the chord? So actually, when we define the chord in the second line, actually you're going to identify the difference between them because the chord we have an initial point and ending point inside the circle, and the second line is overpasses the interior side of the circles. But we have a definition precisely. A chord is a segment whose endpoints are on the circle. Again, a chord is a segment whose endpoints whose endpoints are the center whose endpoints are on a circle, are on the circle, sorry. So in conclusion, as long as you can see in the picture, we have an initial point over here and we have a final point over here. Both are endpoints. We have one initial, one endpoint inside the circle. And probably you're going to ask me, well, Mr. But is that the case? A radius could be a chord. Of course it could be because we have a one initial point and one ending point. But the difference between a radius and a chord is precisely the difference between the radius is because the initial point always going to start from the center. And the endpoint will be any part of the circle because the chord not necessarily the beginning point will be at the center, will be any point on the circle, and at the beginning point, the ending point will be another ending point. Another example, the diameter could be another chord because the diameter, we have an initial point over here, and we have a final point there because it's split the circle into similar parts. For that reason, the radius could be a chord, but we differentiate between them by the definition because the diameter is split the circle into segment by the half, exactly by the half. Not necessarily the chord will split the half of the circle, but a diameter is including into the family from the diameter. Okay, that's why. And if you ask me, what will be the diameter? Just to explain you already, the diameter is the segment of the circle who split the circle into parts in the traditional definition, right? But if you read the definition for the textbooks, mention, okay, the diameter is a chord, just like I explained a few seconds ago. It's a chord. Why? Because we have initial point and ending point inside the circle. that contains the circle of the circle. This is basically the distinction between the diameter and chord. Actually, the diameter is including the family and the chord, but the difference between them is the diameter. Even though this is a chord, between these 2 points, they're going to have the center of the circle. That's why it's the definition between the diameter. Now, what is the second line? Definition for the second line. The second line, o la línea secante. As soon as you can see the difference between the cosecant is obviously when you see the picture on the problem, okay? The second line is a line that intercepts a circle that intersects a circle in 2 points. In 2 points. So if you see, this we have an interception, but never says that we have an initial point and ending point, because as soon as you can see this arrow, that means we have an infinite solution for that situation. Now, what will be the difference between a secant and a tangent line? The secant, the tangent line. Well, actually, in the tangent line, well, we have, this is a line, actually, as soon as you can see, is located in that plane of the circle, actually, as soon as you can see. But intersect exactly the circle into similar points. So, let me see here. Yeah. In one point, it's a line that intersects a circle in 1 point. In 1 point. That will be the difference between one and another one. Actually, this 0.8 that will be located over here is located over here. So I don't know if you can see the difference between them. So second line, we have the infinite line, but intercepts 2 points of the circle, one here and one here. And that tangent line, not precisely could be downward, could be upward, could be down both sides. But in this situation, this tangent line will be the line that intercepts the circle in one singular point. I mean, we have the point A and the point B, the intersection of the tangent line or the point of tangency, that will be the letter B, because we have the intersection inside the circle, but then the second point, it's outside the circle. That's why we have the, the difference between the location of these points. Okay. I don't know if you have doubts or questions onto this part, or everything is clear with the definition between circles, radius, chord, diameter, secant line. Sorry. Questions or everything is clear?
Everything is clear, Miss.
It's clear, right? And actually, you can read the definition, but if you see the picture of the problem, you can identify precisely what will be the difference between them. Again, just for a little review, what is the circle? Is the segment points, equidistant point located in the same plane. What does that mean, equidistance point? Equidistance point means same distance. What will be the radius? The radius is a segment whose endpoints are the center on any point of the circle. Or in simple merely points, it's a line which starts from the center to any point of the circle and split the circle in 4 parts. That could be another definition for the radius. What is the chord? A chord is a segment whose endpoints are on the circle. And the diameter is the chord that contains the circle of the circle. So actually, if you read the definition of chord, segment whose endpoints are on the circle, initial endpoint, the radius and diameters, the radius and diameter could be considered belong to the family for the chord. That the difference between them is the chord specifically, they're saying you're going to have 2 endpoints, one for one side, the another one. The diameter, the, the line to split the circle in 2 parts, but they have a chord, have initial, ending point in between they have a center. And the radius, the same initial point will be the center from the circle. That's why the second line it overpasses obviously the circle, but going to intercept at least 2 points. However, the tangent line will be one tangent that will be intercepts only one singular point inside the circle. In that interception point, it will call the point of tangency, just like the picture of this problem. And we have a few exercises that you're going to see. This is not big deal, no situation, because this interception points, obviously that's supposed to give us um, a perpendicular space. For that reason, we have to looking for what will be the relationship between them. So let's going to give you an example or the example number 1. And you're going to see this is now big deal. Now they oh, this is so difficult. In the first example, it says in the diagram, comma B is a point of tangency. Remember, point of tangency because the tangent line intercepts one singular point inside the circle. Sorry, inside the circle. Find the radius R, period. Find the radius R of this picture means circle of circle C. All right, let me draw the picture of this problem. There you're going to see this is not complicated thing. You're going to see this topic is piece of cake, and you're right. This topic is piece of cake, no big deal. Vamos a ver por aquí. Ay, ya se me deslizó. Pero bueno. All right, this is the circle. A, B, and C. B, and C. All right. What are the values? The values are 50 feet, we have R, and the distance between R and C, sorry, R and B, that will be 80 feet. 80 feet. Okay, guys, as soon as you can see. So the problem mentioned in the diagram B is a point of tangency. So the point of tangency will be located over here. And they're asking for what will be the radius of the circle C. In this property, because the radius is the distance between the center for any point and the equidistant point, that means this distance, the ratio for any equidistant point on the circle, we're going to have always a perpendicular intersection. I mean, this arc with this arc has a right angle. So as soon as you can see, if you're taking, or we are destroying the picture of the circle, sorry, and we're taking a look only the points A, B, and C, we have a right triangle, right? Yes or no? This is the right triangle. And the question is, we have to looking for what will be the value from the radius. It's simple. Remember, guys, to find out what will be the ratio of this triangle, remember we must to apply the Pythagorean theorem. C squared equals A squared plus B squared, where C, that will be equal the hypotenuse. What will be the hypotenuse? Remember, the hypotenuse will be the value who's located just in front from the letter, from the right angle. And then this situation will be 80 feet. The second power. What will be 8? 8 will be the shorter leg, or the leg was just in front of that big angle. I mean the vertex 8, or the smaller one. That will be R, second power. And the letter B will be the distance between the point A until the point C. That obviously we have 50 feet plus R at the second power. Okay, guys, before to continue solving this problem, did you understand the relationship between them? Yes or no? Did you understand?
Yes.
All right, then. So continue. 80 second power will be 6,400 feet square equals R square plus, okay, how to solve in that expression? Remember, guys, the special formula from factoring, the special product, if we have A plus B, second power, that will be equal to A squared twice AB plus B second power. So simple merely words, we got 50 feet, second power plus twice 50 feet times R plus R squared. So what we're going to do, what we're going to have, 6,400 square feet equals R squared plus R squared will be a 2R squared plus 2 times 50 times R will be 100 feet R. And finally, 50 por 50, 5 por 5, 5 por 0, 5 por 5, 2,500. Square feet, right? This is going to be the relationship between them. So what are you going to do? What will be the next step? Well, this is the next step. My dear student, we have to solving this quadratic equation. But we have we don't have much time to solve on this one. Tomorrow, if God wills, we're going to continue solving this equation because we don't have much time. I'm going to take a picture of this photo and I'm going to send you into the WhatsApp group, okay? And tomorrow, if God wills, we're going to continue solving the equation, okay? So guys, thank you so much for your attendance. Have a great and wonderful day. See you tomorrow if God wills. Take care of yourself.
Bye, mister.
Bye-bye. Take care of yourself.